Are you a typical university student who has to do housework such as gardening but online class make you too busy to take care until the plant wilts away? What if we tell you that you can solve these two dilemmas at once? Okay, looks like we can start brainstorm the design.
Now let's design. And here is
CAD model
I designed.
And also the electric circuit diagram. Basically, we need a Raspberry Pi, X power adapter, GRV growth moisture sensor, 5 volts relay module, pump motor, water pipe, cut USB cable with adapter, female to female, female to male and male to male jumpers, as well as some alligator clips. You will also need to have 2 casings, one with holes made to facilitate the wires and another to fill in the water and place the pump and the pipe. Next, connect your Pi to the VNC if you need it. Open up a Python IDE like Tony on the Pi and let's start coding. Before that, you'll need to make sure the latest version of Python is available for your Pi, which in my case here is version 3.7. You will have to import rpi.gpio as gpio, date time, and time. Initialize the coding as false to ensure the code did not run unless the soil moisture sensor detects the soil as wet. Type out gpio.setmode (gpio.board) to set the pin numbering scheme. Define the last water status to create a text file to inform the user when was the last time the plant is being watered. Code out to enable the soil moisture sensor to detect the water content in the soil. Define auto water. You can set the relay to have 5 seconds delay and define the pump pin and the water sensor pin to their respective GPIOs. Print out some status to alert the user the current water status. Create a try statement to detect the water moisture is around 10% and the consecutive water count is below 50%, and add an if statement to allow the relay to channel electric current to pump the water out for the plant. Finally, define a pump on to enable the code to create a text file to inform the user when was the last time the plant is being watered. Create a new coding to automatically run the code whenever you need to run the system to automatically waters the plant. Now we shall assemble the system as in the CAD assembly file and the electric circuit diagram. Place the Pi and the relay in the casing with holes. Connect the wires required for the moisture sensor using female to male and male to male jumper wires to make the sensor long enough. Then connect the Pi with the relay using female to female jumper wires. Then I realized that I had to put the female to male cables through the opening first, so after reassembly, unscrew the NC and COM port on one of the relays and insert 2 jumper wires in both the NC and COM ports. Fasten it and close the casing. Bring it to another place and start to assemble the cables, alligator clips on the USB cable and motor pump. Prepare the second casing, pour some water, connect the pipe to the pump, USB cable to its adapter, and start switching on the adapter. Probe the moisture sensor into the soil of the plant and place the pipe properly on the plant. Alright, let's start run the code. Oh shit! Oh shit! Oh shit! Oh! Oh! Turns out the pump is actually strong enough when delivering out the water to the plant. In fact, too strong, so you actually need to have the pump secure on a pole like this. This is just my tripod stand. And now the thing should be alright, let's retry again. Yep, it works. So we can calibrate the system, which includes the time delay for the pump as well as the trigger for the soil moisture to inform the user when the water needs to water by adjusting the threshold moisture value. So in short, this project is an introductory concept on how much we can do with a mechatronic system to fully automate our daily life, in this case, gardening in general. I hope you find this video enjoyable and informative, and thank you all for watching.